lock into our math genius. We want to tap into that. All right. We're going to get into all this math. I'm excited for us to come together again tonight and talk about some things as we get ready to start the school year. There's some people who are in year-round school who have already started back, and then there's others of us who are in traditional who were it's on the cusp. It's on this way. So without further ado, I would love for my partner Akil to introduce himself, just in case we might come across a timeline of somebody who has not met us yet.
So good evening. My name is Akil Parker. I'm the CEO and founder of All This Math, a company with a goal of improving the relationship between mathematics and the Black community overall. And we offer different resources such as books and also our YouTube channel. And we also offer private tutoring. And we like to have positive conversations about mathematics to help people become more comfortable with math. And I'm heavily influenced by my three children, who I have taught a lot of math to and continue to teach and facilitate their mathematics learning.
Absolutely. Thank you so much, Akil. Dana, we are happy to see you. Let the people know who you are and what you do.
What's up, y'all? How y'all doing today? Can y'all hear me?
Absolutely.
Cool. So my name is Dana Harris. I am the Chief Academic Officer of Young Gurus Math Tutoring, which is an online math tutoring platform. I also have a YouTube channel as well, Young Gurus Math Tutoring, and plenty of video content out there online. And I think between you two, I got some fire under my tail for my book as well. So we're making some progress now, finally.
Let's get it. I love it. So Akil has all this math that's available on Amazon. And then I'm dropping my workbook on September the 1st. Excited about that. It'll go live September 1st. And then Dana just said he about to drop that heat too. So, we got.
I got it. We got to make sure the team is getting better and better.
We got to get that resume we building. All this expertise, we're trying to provide it to the people, all these different resources in various mediums. Some people learn with video, some people need pencil and paper. So we're going to provide those things for you in whatever way that you learn best. But let's go ahead and get into tonight. All right. So we're going to start off with our math myth buster. This guy right here, I love him. I love this guy right here. I had seen the meme and used the meme several times before I even watched the actual video where he's talking about it, which is crazy. But tonight, our myth buster, what we're focusing on is kids or people who feel like, I don't need to write nothing down. It's all up here. I got it. So I want you guys to weigh in on somebody who may have that thought process.
All right. I guess I'll go first. Yeah, man. Mental math is great. But as you get into the higher levels of mathematics, even in elementary school, there will come a time where you will have to organize all the stuff that's up there and bring it from up there to on the paper, because you got to think when you get into these DOK level 3 and level 4 questions, these questions have several parts. So you might have to read a prompt, you might have to create an equation or an expression, and then you might have to simplify that expression or solve that equation. And then even when you do that, it may not ask you for the actual solution. It may ask you for a piece of information that you needed to find the solution. So when we start getting into these higher order problems that have several steps, it's going to be imperative that you learn how to not only write this stuff on paper, but write it in an organized format on paper so that you can streamline your thoughts and just watch the progression of how the problem, how you arrived at the solution.
Absolutely. Akil, what you got?
Mute.
You on mute.
Okay, yeah. So for one thing, I know a lot of students think that because of the way they just interpret and deal with math, they see it as a flex to be able to do the math without writing anything down, like almost like on some like they Jay-Z or Lil Wayne, like I don't even write my lyrics. I freestyle everything. Everything's off the top of the dome. So they like feel that way. But that doesn't really apply here because you want to have notes that you can actually refer back to. And also, if you do make a mistake, you want to be able to find your mistake, because it's going to be very difficult to like remember, like you went through like a thought process in a 5-step problem. How are you going to remember where your mistake was? Because you're only really going to remember your answer, right? So you want to have some type of documentation. It's like I say, like, documentation beats conversation any day, right? So the same thing applies in a math scenario, right? You want to have the documentation so you can be able to pinpoint like where your mistake was if you did make a mistake, or if you didn't make a mistake, you want to be able to go back and say, okay, this is a model for how any problem that I see that looks like this can be done and should be done, and I can just go back to it. And I have a resource and I have a reference, and then my notes end up being an actual textbook. My notes are my actual textbook, and my notes can be used like in the future. Like I can go back to it, or maybe you might have a younger sibling, little brother, little sister, little cousin. They might take that class in the future and like, here, here's my book. Like, guard it with your life. Like this is very valuable. And I got good immaculate notes and everything. So you want to like, I want for children to think about that, and for students to think about that, at whatever level they at. And also too, like to like Dana's point, when the problems get more complex, you're not going to really have the ability to do everything in your head. Oftentimes, like I could start out like teaching, I'm sure we've all had this experience when you're teaching like 1-step equations, like how to solve 1-step equations. And it's like, 2x equals 14. And then the kids are like, if they have a basic understanding of the concept of what an equation is, oh, that's just 2 times what number equals 14? Oh, that's 7. Well, I got to write something down for that. What I need to do that for? Like, that's not that deep. And I'm like, okay, yeah, this is true. You can kind of intuit what the answer is, right? But you should develop habits that will sustain you no matter how complex the problem gets, because they are going to get more complex. You're going to be doing problems that you got multiple variables on both sides of the equal sign. You got parentheses, you got fractions, you got a whole lot of stuff going on. And when you see those problems, you ain't gonna be able to do that in your head, unless you're doing trial and error method. And trial and error, you can be sitting there for like 6 or 7 hours before you come up with an answer. But if you have a method that even those problems, you can knock them out like within, with a short period of time. So it's definitely key to, write things down and get into the habit of writing things down.
Yeah. You mentioned Lil Wayne. So I remember seeing a video on it might have been on TikTok or one of these social media sites where a fan went up to Lil Wayne and they was spitting them lyrics at him and they was feeling it, like they was excited. This is their moment. Lil Wayne was like, okay, because he had no idea he said that. He's like, oh, I said that? And they were, yeah, that's your lyric. Like, so they done missed the whole moment for them to have this connection, because he didn't even realize he wrote the lyric. And I only bring that up, one, because you mentioned Lil Wayne, but two, because you could have this huge aha moment and completely miss it because there's no record of it. Like even when you said something about 2x equals 14, well, something simple like that, you may feel like, oh, I don't need to write anything down. But when we write it down, it forces us to look a little bit deeper. So yes, I can see that it's 2 times 7 would equal 14, but what is another way that would allow me to figure out what the solution to that equation is? And I think writing it down forces you to maybe look at it a little bit deeper. So I'm glad that you guys both brought those things up, because like Dana said, it's not always going to be so simple. You're going to get those multiple steps. So we got to have a reference point or start to build our textbook, like you said, Akil.
Yeah.
So I went and I pulled a couple different things. I went and pulled an article about different notes that structures that people can use in the math classroom. So the first one is like this 3-column structure where obviously you're titling it. You want to kind of give yourself, you want to let yourself know what it is that you're working on that day. So if we're talking about linear equations, are we talking about surface area, whatever it is, titling it. And then you have these columns that kind of separates things where your key topics, your problems, your notes. So this is the 3-column method, is what I found online. The second one was the Cornell method, where again, it's kind of creating these sections. You got your main ideas, you got your notes, and then there's like this summary here. So the only main difference that I see between them is maybe the way they label it, but I think ultimately you're still organizing. You're still talking about what is it that I need to highlight? What is it that I need to take away from this lesson? And then you're having something there that you will be able to reference. Okay. So another thing that I found is that in addition to the structure of your notes, you can also use these different tables and visuals to help you kind of organize your thoughts. Now, I love using the Frayer model when you're talking about terms because it allows kids to kind of do comparisons, especially like if you're talking about linear, you start to look at those examples and those non-examples, the Frayer model really helps them. So I kind of wanted us to start off tonight's session looking at some of the things that are available out there. You got your 3-column, you got your Cornell, you have structures or visuals like the Frayer model. And then I wanted us to take a look at different tasks that students may be engaged in their class and think about how could they create the notes for that. Y'all ready?
Mm-hmm.
I'm gonna take this trip with me.
Yeah.
All right, cool. All right, so first up is this just an invitation. So I want, as we go through these next 4 slides, I want you to think about how can we document our learning in a way that is organized, that emphasizes vocabulary, encourages critical thinking, it highlights those key points, uses some type of visual aid possibly, and is easy to reference. Now, that's a lot of bold. That's a lot of things to think about. And on top of that, we got to figure out how are we going to stay engaged throughout this.
Right. Can I
go ahead.
Can I add something?
Yep.
And also, it should go without saying, but it probably does not go without saying that all of this, at least I don't think, can take place unless students have their cell phones put down. Because if you respond in the text messages, while you think you're gonna be able to respond to text messages and look at your Instagram notifications and your TikTok notifications, even if your mom is texting you, even if your dad is texting you or whatever, right? You're not going to be able to really take notes and do that at the same time, especially with, well, really any class in note taking, because you miss one word in a history class that can throw off the whole meaning of the information. You miss one word in a math class and notes that throws off the whole meaning too. Miss one step in a problem, you cooked, because you don't know, like, what's really going on. So
not cooked.
Yeah, the undivided attention is key. The undivided attention.
I'm glad you brought this up. I got a question. I really do have a question. Why are parents texting kids throughout the day anyway? This baffles me when people like, but it's my mom. Does your mom know you at school?
Yeah,
it ain't even know. It's not even an emergency. You know what I mean? Like,
mama don't care that they in school.
Yeah,
it's beyond me. Like, it's just hard for me to understand. The other thing,
but I will say this. When I see him when he was in high school, like maybe 12th grade, maybe 11th grade, I might have texted him just to send him some information with the hope that I wasn't trying to have no whole conversation with him. I'm like, look, like, this is some information you need because I need you to know something for after school or for later, or this is something we was talking about. With my hope is that he's going to take a look at it at an appropriate time. But so I could see that, but even that, I own that. I probably shouldn't have done that, or I should have probably figured out like when his lunch period was. That would have been the more responsible thing for me to do. But also he's in 11th or 12th grade, right? So I'm hoping that he's got the maturity level himself to be more disciplined. But I don't condone that at all. So even me bringing that up is to say that, like, it's like me saying my bad. I know I shouldn't have done that, but I can see how it happens.
Yeah,
right.
I got you.
But it's not something that I made a habit of, because after I'm doing it, I'm like, yo, like I used to complain about parents doing this all the time. Like, why am I doing the same thing? Like, I complain about the parents doing. Like I'm part of the problem now. Right. But yeah, definitely. I'm with you. Like, yeah, that shouldn't happen. Like, whole conversations, because then the kids hit you with the, well, like, as if it's okay. Like, I'm texting my mom. Like, nah, it don't matter.
The other thing is the multitasking. I think that students feel like they can, like, they'll put the music in their ears and they rapping all these different songs, and they're trying to listen in class at the same time, telling me that they can. I haven't seen anything that says that if you're listening to music with lyrics and you jamming along with it in your math class, that this is somehow going to level up your performance. I haven't seen that anywhere. Have y'all?
No,
No, but what I have seen is the research that says if you are playing something with lyrics in your ear, our brain is naturally going to focus on the lyrics.
Yeah.
I don't know where this thing has started. I get it. Some kids, they have like IEPs and things like that, and kids that may have high ADHD, where they they may need, sometimes it's written in their IEPs that they can do things like that. But I think that there's typically some specifics about it. And I think that what has happened is that this generation of young people, they're growing up in the culture to where they have the cell phone in their hand, but then they have the TV playing in the background. And I used to get frustrated when I would see my son do it. And then over and over again, I would have random conversations with parents of students and things like that. And they had the same issue. So I think that that's one of the things that makes children think that they can do it successfully and learn the information. But I think there's levels to it as well. So, for example, I remember being an undergrad and I used to always listen to, I had a specific album that I would study to, and it was The Train of Thought by Talib Kweli and DJ High Tech, but I couldn't have it in my ears. Like I can't have music in my ears. If it's on it would have to be on the other side of the room. Like it was weird. It was this thing about me to where like if it was coming in my ears the wrong way, it would throw me off and I couldn't focus and it couldn't be too loud. But I think that that is very, very important for parents and students to understand that 9 times out of 10, that music in your ears is going to cause you to be more distracted than focused.
Yeah,
Absolutely.
yeah.
Yeah.
I think too. I think it depends on like the level of understanding of the specific topic at hand that the student has. Like I think about like myself, like when I'm trying to do problems to get ready for a tutoring session, right? But it's like I might be, I don't know, factoring quadratic trinomials. Like, and I've been doing this for like 20 plus 30 years almost. So it's like I have a certain like muscle memory with it. So I can almost do it without thinking about it. So I might put some music on and I kind of feel like it feels like the music has helped me because it's like I'm riding the beat while I'm doing it. And it's like the rhythm of the numbers and everything. But I think that that's because I'm at a certain level of understanding. I think
Exactly.
what kids think is like, no, the music is gonna help me. I'm like, you're not at that level yet. Like
Nah.
you're not ready yet. You're not, nah, you haven't put enough hours in. Like you don't really know this. Like you can't wake up in the middle of the night and just start doing these problems. Like there's certain math topics I could wake up in the middle of the night and just start doing them. Like somebody, asked me about, yo, how do you simplify these exponents? What's the division property for exponents? Middle of the night,
Right.
I'm like, what you need? Like, yeah, subtract the top joint minus the bottom joint. Like, so with music playing with that, but then there's other topics where it's like, okay, we're talking about the chain rule with calculus. I'm not as strong with that. I might need to, okay, based on how this looks, okay, I need to focus. Okay, turn the music off. Nah, because we gotta lock in, right? And I think that's the key. Like kids don't understand when they need to lock in. Because when you need to lock in, it's like, okay, no distractions. Don't talk to me. Turn the music off. No TV. It's just me. Well, I'm not gonna say don't talk to me because you might need somebody there with you to help you with this. We might need to have a conversation about how to do this work, right?
Mhm.
So locking in might mean, yeah, like you're tutoring me and like God walking me through this. But nah, I can't listen to Jeezy. Like I can't listen to Jeezy talk about how much coke he sold while I'm trying to do this. Like I can't do both.
Can't do it.
I can listen to Jeezy talk about how much coke he sold when I'm doing something that I like. I'm very fluent with. If I had that fluency, what's the term? One of y'all used it the other last automaticity, right?
Automaticity.
When
Yeah.
when you
Yep.
got the automaticity, okay, yeah, then I can listen to like Jeezy talk about what he been doing and what Nas, and I can listen to them like because I got the automaticity. But for the students, they don't have the automaticity.
Right.
They
Right.
think they do. They like, oh no, I know this, or this, as if, or like y'all was saying that they're confused into thinking that this is gonna help them to understand it better.
Hmm.
It's like, nah, it's not gonna help you understand it better. It's just gonna distract you.
This made me think of have you ever seen you know how in our community there's things that we all do, even though we might not have ever met each other, but somebody
Head
that you know
nod.
have done it, or either you did it. So one of those things that I've seen on Facebook is like when you parallel park, how you got to turn your music off or all the way down. That's what it made me think about.
Yeah, yeah.
About
You try
how
to
you
get the
got to
angle
focus.
right. You got to get in there. You got to get the angle right. Yeah.
I parallel park with my music blasting still.
Oh, I know that's right. I know that's right. Okay. All right. So we're going to go ahead and jump into it. But before I go to our first activity, I kind of want to talk about something that Akil and I were discussing prior to going live on Facebook. So we were talking about some of the things that we noticed with the way kids take notes now. So parents, when you come into contact with this, these are things that you should be looking for so that you can correct. So I was in a training today and they were talking about, do you teach behaviors? The answer is yes. We got to teach and train the kids the right way to do it. Otherwise, they're going to just do whatever, whether it's productive or not. So one of the things that Akil mentioned was the kids picking random pages in the notebook, like not even starting at the beginning with their notes. Something that I've seen is, kids don't even write on the left side of the page. They don't even know what side of the page to really write on it. And I don't know if that is a product of doing so much stuff online or what, but the pages a lot of times will be upside down, like the holes, fresh piece of paper, but the holes are on the right. Why are your holes on the right? They didn't know. They have no idea. So teaching them that. So what are some other things that you guys have seen in your classroom that your students are doing with regard to their notes that is not helpful?
The my pet peeve, the one that I always talk about, is students not knowing the difference between scratch paper and showing their work.
Okay.
And so they may be taking notes, right? So they might be writing down examples, and then they get independent practice example that they're supposed to put in their notes, and let's say they're trying to solve a multi-step equation, and they need to figure out what 84 divided by 7 is, right? And they're not sure. Well, they mix up the multiplication piece or the trial and error of trying to find out the quotient of 84 and 7.
Mm-hmm.
And so now it interferes with their workflow. So instead of having an equation that they're solving that they can read left to right as well as top to bottom, now there's a mix up because this extra stuff is all in there in the mix, right? So that's one, knowing the difference between showing work and scratch paper. Another one that I've seen is students not necessarily labeling in regards to like the topic. So like at the top of your page, hey, solving linear equations. You know what I'm saying? I think that's important, but I think it's also a learned behavior. Like teachers and parents have to force kids to model that behavior. So like for example, when I do notebooks at school, right? I tell them, "Hey, your notebook has to have the date, it has to have the title of the lesson, it has to have all these different specific things that I'm going to be looking for, because if you want an A, I need you to write this information down at a level to where if you actually utilize this resource, you can go back and it's organized and you can study the night before or a couple nights leading up to the test, and you can go back and remember some of those formulas, some of those specific problem types. So now when you see that problem type, it's going to be different numbers, but oh, okay, well, I know in this particular problem, I need to start by doing this, or I need to apply this formula.
Mm-hmm. Mm-hmm.
So yeah, that's a couple of things that I noticed.
One thing I want to add in here from what you were saying in terms of the student knowing the difference between showing their work and having scratch paper and then labeling their work. I think, and I know I was guilty of this whenever I first started, is assuming that kids know how to take notes.
Yep.
So when I went into the classroom, I started out teaching ninth grade. So I was doing foundations of math and I was doing math one. So as a fresh teacher, I'm thinking, boom, let's just go ahead and jump in here. not realizing that I got to give them the framework. They need to have the structures, and I can't assume that they know how to do anything. And I think sometimes that is where we fall short as the adult in the room, is assuming that because they're at a specific grade level, that they have all of these things, that they know all of these things, when that's not the case. So I think, again, we got to stop assuming so much. And there's a lot of people who talk about that math doesn't have to necessarily be organized. Like you hear the people on podcasts and some of the big names talk about, it can be messy. It doesn't need to be this or that. Write in your pen. I know one of y'all like to write in pen and things like that. It can be messy. And I agree. I feel like there's a place for both, because the messiness shows the thinking. Like I'm thinking, I'm working through,
Right.
the productive struggle. But I think the organization is what I'm going to refer back to. Because
Yes.
sometimes that messiness, sometimes it's like, oh, I'm trying to figure out what was I doing? Because that's that scratch paper where I don't have to be necessarily perfect.
Mhm.
So I know, Akil, it looked like you want to add something in there. What you got?
I think if they're saying that they're encouraging messiness, I think it should be like a type of ordered chaos,
Okay.
right? Because it could just be like a lot of stuff all over the page, but where you can still follow some type of like pathway. Like, okay, this was step one, and then there was step two, and then maybe step three is over here. Maybe it's going in like a circular motion, right? As opposed to like a rational number, like it's some pattern, right? Like the decimal goes on forever and ever, but it's like it's some pattern though, right?
Okay.
Not like an irrational number like pi or whatever. But um I think that's the thing. And another thing I was going to say to your original point, and this is something I think that has to be taught, and teachers have to allow time for students to be able to do this. Because I'm thinking back, like in my own instruction, I don't know that I allow enough time for students to do this thing that I want them to do, which is to include a narrative along with the problems. Because so many students, even some of the so-called good students, will just they'll just copy everything that you write on the board, right? They'll copy the original equation. They'll do this next step and the next step and the next step and the next step. And this ties into a classroom behavior, which is people being so averse to asking questions. And I just be like, bro, like you have no idea what you just wrote down. And like what a lot of students do is they say, oh, well, it's cool. I got everything written down. I'll figure it out when I get home. 99% of the time, you never figure it out when you get home. It's not going to happen. So, and I use that as like a way to try to motivate them to interrupt the lesson, respectfully raise your hand and say, Miss or Sir, where did that four come from? And I like that, because that's how I understand as a student. Like my understanding is when I'm trying to make sense and make meaning of a math problem, I want to know where these numbers came from. Like where did this plus sign come from? Well, how come in step one it was a plus sign, but in step two it's a minus sign? Where the plus sign go at? Right? It's almost like when I come into my room and things are not the way I left them, and I got questions. Who was
Right.
in here? Like who moved my stuff? Right? So I look at math problems the same way. Like, okay, step one, there was a three. Where the three go at? Don't nobody move. No, we're not doing nothing until you tell me where the three went at. I need to know where that three went at. And then you can explain. Hopefully the teacher can explain, like, okay, well, the three is gone. The three turned into a six because we multiplied everything by two. We multiplied by two on the left side, multiplied by two on the right side. Oh, okay, I get it now. All right, let's keep going. But that type of thing, there's a narrative that's involved with that. So my hope is that students will learn to like write that step out, like either in the margin, they'll write it like above the problem and draw an arrow. I'm real big in terms of my own notes and like even like mapping out my own lessons, like doing a narrative and then drawing an arrow, like to point to, okay, we did this and like this is where that came from, or we moved that and and I draw an arrow to it, but I explain it out like in the margin somewhere. Um, and I want students to do that so that when they do get home, they're like, okay, they have actual instructions for the
Right.
problem. Because otherwise, even if they copy everything from the start to the finish, and they don't really know what they copied, they're just copying everything down. They don't know how they got from the original problem to the five steps they had to go through to the final answer of x equals 2, right?
Right.
Like how you know x equals 2, and then you don't know enough to know about all those steps, and even if they're not using like the textbook, like or the more traditional names for like the properties that are used, like, you know, division property of equality, or this was, you know, the multiplication, the addition property of equality on both sides, or we use the distributive property. Even if they're not using that, even if they just say like, all right, look, we multiply by 2 on both sides, or we, you know, had to get rid of the 3. How do we get rid of the 3? We had to subtract it because that was the opposite operation. Like, I want them to be able to do stuff like that. But I'm also thinking of ways to make that realistic, because but depending on who the teacher is, there's time and there's a time crunch involved.
Right.
You
So I
know?
think one thing to think about from the teacher standpoint is how you structure your class.
Yeah.
So I know Dana is familiar with the open up resources. You know, we start off with the warm up, then we got our activities, and then we have our lesson synthesis at the end. So majority of your note taking should come around that lesson synthesis, because that's when we're bringing all of our ideas together. That's what we're highlighting the definition of the vocabulary and academic terms that we've discussed. That's what we could be creating our anchor charts at this point. We're really trying to consolidate all of our learning. So when you talk about not having time, or maybe not giving the students time, the lesson synthesis, when you start to consolidate your learning, is when that could probably take place. So all the other stuff is more so, I guess, where, like Dana was saying earlier, kids could be using their scratch paper, because now we're kind of exploring, we're going through things, we're figuring some things out, and then we'll kind of more so solidify it once we get to the end. But we're going to get into our task, and I have, I think, 4, 6, 7, 8, and then 9th grade. So let's jump into it. All right, so for our first one, the objective here that we would present to the students is I can identify corresponding pairs of base and height of any triangle. Okay, so you guys will notice here that we got 3 different shapes. They're telling you which one is the base, and then they're wanting the student to figure out what is the corresponding height. So on the note-taking examples that I mentioned, there were, let me go back real quick. We had keywords in ones, problems and notes for the 3 column. And in this one, we had main ideas, notes, and summary. And then the Freyer model is where we're taking specific terms and breaking those down. So what I would like for us to do is take some time to think about these, how we would label those heights. But then I really wanted to kind of dig into what would our notes look like. So I'm gonna give you guys a moment to look at each of these, and then we'll talk through it. All right, so again, we got 3 images here. We got 3 triangles. Each of our bases, they've given us a letter to represent the base, and we have to find the corresponding height. So before we jump into how we would do this, what do you think would be the keywords or the vocabulary that the kids would need to know to even be able to work through this?
Obviously base and height. I think that they would need to know interior and exterior angles.
Okay.
Or just interior and exterior.
Okay.
Interior and exterior.
Okay, so I'm gonna remind you this 6th grade.
Oh.
You still think they want it? You still think? I mean, I can write it down.
Nah, not for 6th grade. Uh, maybe dimensions.
Okay. I'm gonna give y'all one.
I was
I
gonna
was
say that.
thinking that.
Yeah.
Okay. All right. What about And this index card is here for a reason. I'll tell you why in a minute.
I got two I want to add.
Hit me with it.
Vertical and horizontal.
Okay.
Yeah.
Okay. So any other words? Am I missing anything?
I mean angles, but I mean we got right angles, so angles.
Okay. So we're gonna roll with what we got.
Corresponding. They need to know the term what corresponding means.
Okay. All right. So these are our keywords so far. So I'm just going to start with the first one, and I'm just going to highlight the base. So it says that A is the base. So we already said that the kids need to understand what base and height are. Now, the next thing is the relationship between the base and the height when we talk about this triangle. So now we already got the key words down here. What's the key word that's going to help them understand or help them recall the relationship between the base and the height?
Perpendicular.
Yeah.
Yep. So they got to understand that the base can be any side, but the height has to be perpendicular to it. So again, as we're working through this, think about the notes that we want the kids to eventually have. So if it's perpendicular to it, that means it's going to create that right angle. So it's going to look something like that, right? Going through that opposite vertex, and we create that right angle there.
And so this is also where I would add in the terms vertical and horizontal.
Okay, tell me more.
Because like if you look at the triangle where B is the base or even where C is the base, some students will look at that and they say, okay, well, the height, it's like they would say, well, side C is the height in the triangle that has B for the base, but it's slanted though, right? So understanding a vertical, what vertical means and horizontal means, and even tying it into the XY plane with the X-axis and the Y-axis, how those are perpendicular to each other. But how, like in the first triangle that we're working on now, how we had to create the height. We had to create it because it wasn't already drawn for us. Like sometimes the height is already drawn, it's given. It's part of the actual picture or diagram. But
Right.
with these, we have to actually create it on our own.
Right.
And I think that can be I mean, not if you're not accustomed to doing it, if you've never done that before, it might be a little confusing because you expect it to, yeah, you expect it to be like part of the triangle, especially if like you're originally introduced to triangle, like right triangles. So you start out with right triangles and you just like, you become accustomed to, oh, well, that's the height, that's the base, that's the height, boom. And especially if you're trying to find the area, it's like, oh, just multiply this side by that side. So then I get to a lesson where nobody might not have explicitly told me that, look, your height is not always going to be given, right? Sometimes you're going to have to draw it on your own and then figure out what it is. So then you're looking at this triangle, you're like, I remember we was doing last week and that kind of looked like a right triangle. I don't think it is, but like you as a student, you might be like, it's going to be a right triangle today. And then you just think that C is your height, right? But not understanding that like that actual definition of, okay, well, the line, like what you did already in the first triangle, the height is always perpendicular to the base.
Mm-hmm.
Just knowing that as a rule, and then understanding what perpendicular means, and also like I think the height being perpendicular to the base, also is like mirrored in like a vertical and a horizontal line. So you got a vertical line and a horizontal line. So that's what I think about. I just would like to have would try to have that conversation because I know it's going to be students that's going to look at, or even the example at the bottom, like, oh well, I think B look like it's the height, and I've had to explicitly say to people like, nah, your height is never slanted. Like this ain't like the, what is it, the Leaning Tower of Pisa, like over in Italy, like, you know what I'm
Yep.
saying? Like, nah, like our height is gonna be vertical, you know. That's what it's gotta be. It's gotta be vertical. And it's gotta make a right angle. It's gotta make a right angle with the base.
So when you say the height has got to be vertical, you just mean it needs to be a straight line versus slanted, right?
A
Because
straight
remember, with the triangle, they can use any side as the base as long as the height is perpendicular to it. So it's a chance that the height might not necessarily be like that.
um
Even though I know conventionally we label the height like this, but in sixth grade they're going to see heights that are not always going to be up and down.
so the height could actually be hard. Well, so the height could be horizontal, but it would still be perpendicular to what we consider the base.
Yes. Like this whole lesson is about students being able to look at the triangles and determine the base and height pairs. So I only picked out this one section of it,
Mm-hmm.
but there could be a base that they chose that's vertical. So that means the height is now going to be horizontal.
Hmm.
So that means, so to that point, basically in this first example, if C was the base, you still would have to draw that height externally because
Yes.
there's no right angle in there.
Yes.
And as we talk about this, what this is one of those moments where I'm thinking from the mind of the kid who's confused. And y'all, I'm gonna throw this out there because I just kind of came up with another definition of kind of how to remind them how to find that height. It's got to be perpendicular with that base, but it has to go from the base to the highest point
Yep.
on that triangle.
The opposite vertex. Yep.
Okay. All
Mhm.
right. I just wanted to see if that was okay because I'm thinking in both of those other two examples, the opposite vertex is outside of the triangle. And
Mhm.
and this is crazy. And this is like why the language is so important that we use. And sometimes, even as experts who've been doing it really long, we have to slow down with our language because perspective is different sometimes. Like when we talk about straight lines and slanted lines, there's a kid that thinks each of those lines is a straight line because
Correct.
it's not crooked. You know what I'm
Correct.
saying? And
There's no
so
curves
that,
in it. Yep.
yeah, those are the things that come to mind to me. But I would, in something like this, I would make sure that the students understand that the height has to be perpendicular to the base, and then it has to actually go up to, excuse me, that highest point.
Mm-hmm.
And then other kind of shapes of triangles come to mind when I think about this.
Mm-hmm. So then the reason why I had the index card here, I meant to do this while I was still in Canva so I can move the index card around because if you were in class, you could give the student the index card so that they can use that to line up and create those perpendicular lines with whatever your base is, so that they could see what it would look like. And then when you brought up about it may be on the outside of the triangle, then they would be able to see that I can just extend that line and see that my height is here. And the same thing is true for this one.
I think that's something that I had trouble with as a student years ago, just the concept of the height not being inside the triangle.
Yeah, I think a lot of kids, it's tough for them to get that, to grasp it, because when they think about the height of things, they always think it's like it's a part of something. If I'm talking
Mm-hmm.
about the height of this book, it's
Yeah.
touching the book. So and then now you got to go into explaining to them, well, this is 2D. And so now because it's 2D, that's why it might be a case like that.
Mm-hmm. So the next question is, what would or what should the notes look like as the kid is wrapping up their thinking with this and looking at the relationship between the base and the height, and they have all these different terminologies that not all of them are necessarily new to this grade level or to this lesson, because I pulled this from lesson 10 of unit 1, lesson 10. So this is not the beginning. We about to wrap it up. So what do you think the notes should be for this particular lesson? And thinking about, like, as a parent, something that they could then look at too and be able to help their kids at home. And then as well as the kid being able to reference it and understand what they got. What should the notes look like?
I think Cornell notes will be a good one for this one,
Okay.
because you can take each example and you can draw it on the right side. So you draw the picture on the right side, and then on the left side you put notes about why the height was outside of the triangle in the corresponding examples versus the ones where the height is inside of the triangle, and why.
Okay. All right.
And I think in that summary phase, it should definitely say height must be perpendicular to the base, and it must go to that highest point.
Okay. So with my pictures, I probably want to make sure that I get somewhere that height is within it, but also I
Yes.
have to extend a line to create it on the outside so that I
Yes.
can represent. Boom. All
And
right.
that's another, just a side note for parents. Those notebooks that have the graph paper in them,
Yeah.
they work phenomenally. They
Mhm.
work phenomenal for mathematics. And it helps your kid doodle a little bit if they're that kind of kid. Got some doodling space.
Love it. All right. Okay. So that's sixth grade. Moving on to now seventh grade. Okay. So we have a rectangular parking lot. It's 120 feet long and 75 feet wide. Lynn made a scale drawing of the parking lot at a scale of 1 inch to 15 feet. The drawing she produced is 8 inches by 5 inches. Diego made another scale drawing of the parking lot at a scale of 1 to 180. The drawing he produced is also 8 inches by 5 inches. Okay. Explain or show how each scale would produce an 8 inch by 5 inch drawing.
Mm.
So, to give you a little context of this lesson. So, again, the whole point of this is for us to talk about notes for the student. Just recalling some of the things that we've already said. Students need scratch paper as well as something that's formal that they can refer back to, right? I want you to think about any keywords that the kids need to know. This particular lesson comes from scaling without units. Scaling without units. Okay, so that's where we get into the Diego piece. So I'm gonna give you guys a moment to kind of think about how you would solve the problem. Then we'll talk about that together and then talk about the notes. Do you think?
Hmm. I need help on Diego's.
Yeah, Diego,
Okay. All right. No problem.
Still
So
need,
before we
or
get to
maybe I need,
solving,
or maybe I just need more time.
okay.
I don't want to give up yet.
Okay, you need some more
Um,
time?
yeah, I need more time for Diego's. Lynn,
yeah.
I'm cool with Lynn. I need to figure out Diego's.
Okay.
Figure out the method to how he did what he did. Yeah, this is productive struggle right now. That's what this is.
Ooh.
Yeah, it's productive struggle for me. Yeah.
I'm interested to see if we end up doing the same thing or different things.
Oh, okay, okay. I see.
All right. So you might not be finished yet, but I want to start talking about these keywords. What vocabulary do you think the kids need to know?
Scale drawing, rectangle.
Okay. Rectangle? Okay.
Yeah, rectangle definitely. Scale by itself.
Yep.
Mhm. Okay, so I'm gonna also put up here.
Definitely conversions.
Yep.
Ratios.
Okay. All right. All right. So let's look at Lynn's because I think everybody's felt pretty good with Lynn. So let's look at Lynn. How did you guys do Lynn's? And I'll tell you how I did Lynn's.
I just took 120 divided by 15 and got 8, and then 75 divided by 15 and got 5. And
Okay.
so basically taking the 120 feet and dividing it by the 15 feet because the uh ratio or the scale factor was 1 inch to 15 feet. So I basically just said, okay, well, how many groups of 15 feet are in 120 feet? And how many groups of 15 feet are in 75 feet? Yep.
Okay. All right. That's Lynn's. All right. Diego. All right. Y'all want me to show you what I did? Are you?
I looked at it.
Yeah.
I'll tell you what I did for Diego. I ended up just thinking that it was just inches. That Diego was dealing strictly in inches. And then I realized that because the final answer comes out to be inches, 8 inches. Well, the scale drawing comes out to be 8 inches by 5 inches.
Right.
The actual parking lot is in feet. the
Right,
dimensions
right.
of feet. So then I'm wondering, I'm like, that number 1 to 180, that's real large. So what if Diego converted 120 feet into inches and 75 feet into inches? And then I
Okay.
kind of just did like a trial and I guess that's trial and error, like just experimented to see if it checked out. And it checked out because it ends up being what's that, 1,440 inches,
Yeah,
feet
by
40
900 inches.
long. Yeah.
Okay, I got that far. I didn't check that ratio to see if it was equivalent to 1/180.
Okay.
Is it?
So I'm just going to show, I just did the same thing. So I figured out what my scale factor would be if I went from 180 to 120, and that
Mhm.
would be 2/3.
Mm.
Okay,
So
so I
this would
was on
be
the right track.
2/3 of a foot. So 2/3 of a foot would be how many inches is basically what the next step would be. So then I did the same thing for 75. This one was I think it was 5/12. So this is 5/12 of a foot. So then figuring out how many inches are in 5/12 of a foot. So I'm gonna show that just in case somebody sees this. So I know that 1 foot is 12 inches, right? And this is 2/3 of a foot. So then I would just be multiplying 12 and 2/3, and I would get 8. And then I did the same thing for the other one.
Okay, yeah. So I
And
just
that would
didn't get
be,
to the last step then.
hmm,
I said I just didn't get to the last step. I eventually started thinking about it like that because I was like, that 1/180, it gotta be the relationship of inches. I'm like, because it doesn't have specifics. So I'm like, that's the only other way I can take it.
this is the one that's really challenging for students in the 7th grade because it doesn't have any units up there. So
Right.
they have to understand that one represents 1 unit of whatever, and the 180 is the same unit. So 1 inch to 180 inches, like you got to convert both of them. And
Yep.
I think that's the part that is challenging or confusing to students. So now that we went through this as the teacher, what are we expecting the kids to have as notes on their paper so they can then review it, understand it, repeat it? What we thinking?
When I teach ratios, I always remind them to go from small to large on both objects or go large to small on both objects. So for example, in this one, decide when you create your ratios with Lynn, all right, I'm going from inches over inches to feet over feet, right? And then when we went with Diego, we didn't know those units, but we're making the assumption, okay, well, if it's going to 180, that's possibly inches because it's so many feet, right? So then now we're saying we're going from small over small to large over large. So
Okay,
making
so
sure they match up the units.
yep, match up your units. Yep. Akil?
I'm thinking like this is one of those situations where even if they copy everything down, which I hope they do, they still need some type of narrative to explain like, okay, where did the 2/3 come from? Like
Mhm.
that's a question. Like under Diego, 1/180 equals 2/3 of a foot over 120 feet. And hopefully they would say, okay, well, okay, what's the relationship? Like relationship between 180 and 120?
Mhm.
Like what's that relationship? Like, or what do I multiply by 180 to get 120? And then I keep it balanced. Like in my fractions, almost like reducing a fraction. If you or if you convert to an equivalent fraction when you're adding and subtracting fractions, right? And you might need to go from 3/4 to 9/12 because 12 is your LCD. So if you had to multiply 4 by 3 to get the 12, then you got to multiply the 3 by 3 to get the 9. So I'm basically like, I know I'm multiplying the 180 by 2/3, so I also got to multiply the 1 by 2/3. but
Okay.
hopefully, like, some type of writing will be done to show that.
So do you think we would go with our 3 column? You think we should go with Cornell? Cornell has what our main ideas. We have our notes, and then we have our summary at the bottom. And then our 3 columns, I think is keywords. Then I think it is what was in the middle? Problems, maybe?
Yeah,
The
practice
notes. Yeah. So which of those structures do you think would be best for us for this one?
I'm not
I
sure.
think the 3 column on this one probably.
Okay.
Because you gotta, like, when you go to that Diego side, it's gonna be a little more you need to kind of take note of.
Okay.
You know what I'm saying?
Mm-hmm.
Like, it's a couple things you got to point out because I think kids get a little more confused with that fraction piece because they
Mm-hmm.
got to realize, oh, this is 2/3 of 12 inches. You know what I'm saying?
Right.
It's 5/12 of 12 inches.
Right. So then here, all those vocabulary words that we talked about,
Yep.
scale, what that is, ratios, pulling it from 6th grade, conversion, 12 inches equal 1 foot.
Right.
All of those things are here in my keywords and my topics. In the center, we can go back to what Akil was saying. We can give them some type of narrative. So maybe this is an instance where we print it and we cut it out and they glue it in there so we can save some time. And then, they can use some annotations and things like that. And now we go over here to the notes section where we're actually proving why, even though they use 2 different scales, the drawing is exactly the same. We're
You
showing
can
that.
put a little foldable in that middle part too.
Say it again.
You could also attach a foldable in that middle part too.
A foldable.
Yeah.
Yeah. Yeah. We could do a foldable there too. So now the students are able to see, okay, I know what a scale is. Now I have this example of what the scale is that I've had some time to kind of think about and work through, giving me that time of productive struggle, because I don't think that it's gonna benefit anybody if we're just writing things on the board and telling the kids just write this down. I don't think that's gonna benefit anybody. So the same way, I gave y'all a little bit of time, we got to give the kids the time to work through it on their own so they have some type of idea. Otherwise, there's not going to be any connection to what's in the notebook anyway. And then, finalize those notes over here on the side. Okay. Anything else you guys want to add before I move on to 8th grade?
This is one of those, I can feel it. One of those, like, well, Lynn, not so much, but I would say Diego's bullet point is one of those I hate math problems. This is one of those. If it's not explained to a way where, because a lot of the students will fold. I can see myself, like, as a middle school student, like, being frustrated at a problem like this, because the Lynn would have, like, made sense to me, because there's like an algorithm to it. Like, I know how to set up the proportion. Okay, 120. All right, 1 inch to 15 feet. Okay, for every inch, that's gonna be every 15 feet represents an inch. But I think what throws me off is there's no unit. I would be mad, like, why there's no unit? Because then it's like, to me, as a student, it's like it's a glitch in the matrix. And then I would just, like, I might have actually shut down, so I can relate. So at times I might not have had the perseverance. What do they call it? Or grit? What do they call it? Grit?
Yep.
These days.
Yep.
But yeah, that 1 to 180, but yeah, I think it has to be explained. So you're like, okay, and then you got to have, like, problems, like, you got to see problems like it. So you got to get a chance to get a problem like that right.
Yeah, they got to practice. Yeah.
This is like a it's like a Oklahoma math drill problem. Oklahoma drill math problem. There's a lot of those. I think about those. Like,
I love it. Hey,
it make you start playing basketball.
Yeah,
you stop playing football.
Make you quit, boy. I thought you was on the team.
I'm gonna Google that afterwards so I can laugh too, because I don't know what you're talking about.
No, go on YouTube. You're gonna see a lot of videos.
It's a football tackling drill.
Oh, okay.
And
they make you go head up.
Yeah,
you gotta go head up, and, like,
you'll quit.
Yeah, if you're not.
It turns most people into football, I mean, into basketball players.
So, and I'm glad that you guys mentioned that, even as math educators. I'm glad you said that, because if you feel like that as an educator, then obviously you're right. The kids are gonna feel that too, right?
Yeah.
If you had that moment yourself. And I think this goes back to what we were saying with our Mythbuster is people feeling like I should be able to do it in my head, because the reason why you immediately attracted or were attracted to Lynn is because, oh, boom, 1 to 15. I already know what to do. Boom, 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 boom.
Mm-hmm.
Diego, this is going to take some time where I got to now slow down. I got to now process what it is that is giving me. How do I apply this to the question that is asking me? So I think this is the whole point of our session tonight. This is the whole point, like getting people to kind of slow down, and it's not always going to be instantaneous. It's not. And you got to be able to, you got to stick with it. You got to see it through, my boy.
It's a slow grind.
It is.
Sometimes it's a slow grind.
Absolutely. So even though I had two more, I think I'm gonna end with the 8th grade, because this one is a little loaded, and I don't want to rush it so much. So I'm going to share my screen my other screen. Give me a second. All right. Can y'all see the triangle on my screen?
Mm-hmm.
Yeah.
All right. So for this next one, we're getting ready to get into transversals, alternate interior angles, things like that, right? So prior to you getting to the activity that I'm about to engage with y'all in, we would have the students to go through the activity that's on the screen now. So with this digital tool, the kids can play around with rotation, which they would have already learned about rotations prior to this particular lesson. And then they're going to use that information to apply to this next activity. So what I'm going to do is we got triangle ABC in the plane, right? So I am going to create midpoints on lines AC. I'm going to also create a midpoint on line segment AB. Okay, so now that I did that, now I'm going to rotate triangle ABC 180 degrees around this center. Matter of fact, let me label this. Right. Okay, never mind. Don't worry about it, because I forgot how to label it. All right, so I'm going to rotate the triangle around this point. Everybody see what point I'm pointing at?
Mm-hmm.
All right, I'm going to rotate it 180 degrees. Okay, so everybody see what we got. So what happened to our prime triangle?
The original triangle?
Yeah. I mean, I'm sorry, not my prime triangle. My pre-image. Excuse me.
The pre-image?
It rotated 180 degrees.
Mm-hmm. Okay, so now talk about the angles. What happened with the angles?
Angle A is now at angle C.
Okay.
Angle B is now at angle at the top right.
Okay.
And angle C became angle A.
All right, I'm about to do the same thing on this side. Okay. So what is the relationship between the two prime images? So the two triangles that I created after I rotated 180 degrees. What's the relationship between them?
They're just a translation.
Okay. Yes, they're
Wait,
translation.
the last triangle that was just created, was that a clockwise rotation or a counterclockwise rotation?
So I'm gonna go back so you can see it. Boom. What you think that was?
It looks like a 180-degree clockwise rotation of the original ABC triangle.
And it was around the other point, actually.
Like it went.
This one.
Yeah, it was around the midpoint of AB.
Mm-hmm. Yep.
Okay.
Okay. So Dana just said that this second triangle is a translation of the first one, right?
Yeah.
So then what does that mean for the angles within the triangle?
They correspond directly.
Right. So let's say somebody's watching that doesn't know what you mean. Give me a little bit more.
So if you look at segment AB, and you slide it to the right and put B on top of point C, then that would be point B, and at the top right would be point A. Okay. So when I say correspond, if I slide segment AB over to the right, however many units, it's gonna be right on top of segment CB.
Okay, so whatever the angles are in here, let's say I label the angles. Let me start over here on the right. Let's say
I
I
need
label these angles A, B, C, right?
Yeah.
They would be right on top of these, is what you're saying?
Yes.
A, B, C. Okay, bet. Yep. So then the reason why they do this activity is because they want students to understand why those alternate interior angles are congruent. So why do you think this activity would help them understand why they're congruent?
It proves it. Like, I've never done this before. I've
Why does it prove it?
I've never seen the connection between transversals and corresponding alternate interior, alternate exterior, so and so forth angles and rotations. Rotations or transformations generally. I should have, but even as a teacher, I've never seen that.
Okay. All right. Boom. So we all learn it together. Okay. So let me show you. Let me go back to my regular screen here. All right. So, all right. What do y'all see now?
Same thing.
Open up still.
Okay. Hold on. Yes. What about now?
Yep. There we go.
All right. Okay. So we went through that whole rotation activity because, like I said, we were trying to get students to understand the relationship between the triangles when they're rotating, but also when they rotate, the position of the angles, and then when they all are on that top line together, how they form that straight line, that straight angle, those supplementary angles. So it kind of proves that the three angles within the triangle are 180 degrees too, because they lie on that straight line. But then it also shows them that those angles line up as well. Tell me if that, give me a thumbs up if that made sense, what I just said.
Say it one more time real quick.
So the activity we just did showed the students, if they would have went through it, that one, the three angles inside the triangle equal 180 degrees, because when they would have rotated them, they would have seen angles A, B, and C, for example, within my image, would have been right all here together.
Okay.
So that would have proved that, number one. Number two, they would have also noticed that, like Dana was saying, when we rotated, that those corresponding angles, they were congruent. Okay. So when we rotated them, for example, if we look at angle A and this angle right here that's not labeled, let me highlight it. If we were to rotate our triangles, we would see that they end up lining up with one another. Gotcha. So that was the point, but I didn't label it on the other screen, which is making it harder to connect right now. But if we would have labeled it on the other screen, we would have seen how those angles would have lined up, which would have proved the alternate interior angle rules. Following me?
Yeah.
A little bit, kind of, sort of. All right. So after the kids did that activity where they're playing around with that, so they wouldn't have did it just one time like what we just did. They would have did it several times so they can kind of see it, make the connections. Now we're here where they are presented with this triangle, and it tells them that these lines, DE and AC, are parallel. Then it's asking them, what is the sum of those angles? And then explain how you know. So what do you guys think about the activity we just did and them now being able to answer this question?
I think question one, number one, it should be a given, because if you understand that DE is a straight line, um, then it has to be 180-degree angle.
Mm-hmm.
So
Yep.
so just when they ask me, once I visualize what DBA is, angle B, and CBE, I'm like, oh well, that's three. It's not a linear pair, but it is three lines, or three angles that form a straight line. So I know that sum is 180.
Okay.
Now, when it says, use your answer to explain why A, B, and C is 180,
Mm-hmm.
well, because now I know that DBA is going to be the same as CAB, right? So I know that's one of them. And then I also know that EBC is the same as angle C, because now I can visualize that they're alternate interior because of that rotation. So when I see that rotation, I'm like, oh, well, that angle's just moving over here now. And
Mm-hmm.
this angle just moving over here now. So
Mm-hmm.
then now I can see that slide. Like if I take that middle part out, I can slide it from right to left or from left to right, and the angles that correspond to each other will overlap.
One thing that I like to think about with the 180 is that now the whatever position I started with is going to be the opposite.
Right.
If angle A started off down here at the bottom, it's going to be at the top once I do the rotation, the 180-degree rotation. So that kind of helps me visualize what's going to correspond to it or its new position. Because I think spatial reasoning, which is what we talked about a couple of sessions ago, is very difficult. Like trying to
It
visualize where
is.
something is going to be, but you don't see it yet, it's
Mm.
hard. It's very hard. So I try to use what I understand about the coordinate plane and 180 degrees to kind of help me process it.
Yeah.
Akia, what you got?
I would need to see, for me, I would need to see the last activity, like, and like really focus in on that more
Mm-hmm.
and get a better understanding of that in order to
Mm-hmm.
like relate it to this. That last activity hasn't sunk in fully
Got it.
for me.
So if I were to extend this,
Okay, so that's the rotated triangle, and that's the other rotated triangle.
Yep.
yeah, now you see it a little
Yeah,
bit.
now I see it. I see it like
Mm-hmm.
looks like the last activity. So
Mm-hmm.
we got A, B, and C, and they're the same triangle, just moved over,
So this would be C, right?
and that's
Mm-hmm.
rotated, right? And then A is all the way out to the far right, and then B is down adjacent to the C. And then for that one, it's wait, so A is adjacent to B. Angle A is adjacent to B in the rotation.
So A would be right
The
here.
rotation on the left side. Yeah, okay.
Yep.
And then the C is out to the far right.
Yep.
Because remember, Dana told us that that triangle was like a translation.
Mm-hmm.
So if I know
Slides.
that C is here for this one, then it has to be here for that one,
Right.
or vice versa.
Just like the A's. So the A's
Mm-hmm.
are in the same space. Okay. And the B's also.
Mm-hmm.
The B's
And
in the
then
same
now
places.
notice how each of the angles from our center triangle are right here.
Right.
So then again, this is what I was saying earlier, how this proves that the interior angles for that triangle is 180 degrees.
Because they
I think
also, as
I
a
think
straight
the
line, they're 180.
Yeah, I think the key is understanding that in that original picture, because what I had to catch up to was the one that's rotated clockwise is rotated on segment BC. The one that's rotated counterclockwise is rotated on segment AB. Once I seen that being the big difference, I'm like, oh, okay, I see why it ends up being just, a translation from this one to this one. But I had to think about that part, because when you first did it, I was like, wait, hold up, we can't be using the same point. That's not gonna line up. So that's what made it make sense to me.
So when y'all was asking about the clockwise versus counterclockwise earlier, if you notice, I was kind of like stuck because I'm like, if it's 180 degrees, it don't matter if it's counterclockwise or clockwise because it's going to still end up in the same position.
Same place.
Very
right.
true.
Difference,
Yeah.
the difference between those two rotations is what the center was. Because one
Yes.
center was on the BC
Yeah.
and the other one was on AC or whatever it was.
Exactly.
Yeah. Okay.
Yeah.
All right.
Rotations,
So then,
I think I have a hang up with this too, because rotations are my least favorite transformation. Like as a student, the reason being is because it depends, like the reference point or the what is it called? Is it called the reference point?
Axis
Like
of rotation.
yeah, like that, like because like I can't. It makes it hard to visualize because somebody says it rotates about a line or rotates about a point or rotates about like the origin I can understand. But then when you say it rotates about other things,
Yeah, it gets tricky. It
yeah,
does. Yeah, I
it
can
makes
see that.
it makes me unable to like visualize where it's actually going sometimes.
I got you. Yeah.
Um,
And
but
I'll be honest with you, my understanding, I think, is pretty limited to the origin because that's what we do in North Carolina in the eighth grade. It's only 90-degree increments and it's only about the origin. So I would probably have to sit down and look at some of the other ones if it was something other than, I think I've done it before, but I haven't done it enough for me to be just like boom, da 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 da. I would have to sit
yeah,
down a little bit. Okay, so we went through this one. And this is again the one I didn't really want to rush on because I knew it was going to take some time. We needed to finesse it a little bit. So, but now we got to think about the notes. So, are we doing our 3 columns? Are we doing Cornell? What are our keywords here? What we got?
Keywords, rotation.
mm-hmm. It's a lot in this one.
Yeah.
Mm-hmm.
Axis of rotation.
Yeah.
I'm gonna also put center too.
Yes. Corresponding. And I would say corresponding angles and segments, both.
Okay.
And I'll let y'all get some.
We didn't talk about this much, but this transversal is what they want you to understand that when you have those parallel lines cut by a transversal, that they have those specific characteristics there. But I was really focusing on the triangle in them, that when we extend those bases, create the parallel lines. But transversal is still relevant.
They don't want them to derive the concept of transversal, do they?
No.
Okay.
Mm-mm,
Because I
they
was
tell them
like,
that.
that's kind
Yeah, they tell them. Let's see, alternate interior. Okay. So which note structure? 3 columns, Cornell.
Whichever has a lot of space for the picture
of,
in the diagram.
yeah.
Okay.
Because do we want to do 3 different pictures, like the original picture with the pre-image, and then another picture with the pre-image and the first rotation, and then a third picture with the pre-image, the image, and the other image? Or
That's a good
would that be
question.
too time consuming? It would help to see the progression. I
Because that
think
would
that
make
might.
me want to put it in the Freyer model, in a sense.
Okay. I'm thinking they definitely gonna need some patty paper, maybe so they can trace the original one and then just line it up with their center and then just rotate it so they can see the new
Yeah.
positions. I'm gonna go with Cornell.
Cornell probably give you the most space.
Yeah. Oops. Yeah, I'm gonna go with Cornell. Okay. Freyer model would be good for them to understand the differences between the types of angles. So like if we're focusing on alternate interior angle, understanding what that is and what it is not, I think that would be good to have with our notes as well. So I'm gonna add that up there, Dana. You mentioned that. All right. Okay. All right. So we did a lot, y'all, and it's 9:30. So you know how I like to wrap it up. I like for us to let the people know, because it's a lot. We talked for like 90 minutes about so many different things. So I want you guys to take a second and think about, how can we wrap this up? What is it that we want parents to walk away with, so that when this new year starts, they feel prepared to support their kids from home?
I would say be patient with yourself. If you notice, anybody that's watching this or anybody that watches this later, you notice there were a lot of segments where I wasn't 100% sure. And I do this for a living. But I think that is part of the process. That's part of, I think, one of the ways that math as a subject has to be rebranded. Whereas when we grew up believing that the person that does math is like infallible and knows everything and is all knowing at all times, and as if we also go through like a scientific process and try to figure things out. It's like, but that's like, like what do they say? Like, you'll never see how the sausage gets made, right? But, so like you really seeing it, like, we're really like interrogating these questions and, trying to figure things out. And like I said, like, out of all the transformations, I like translations. They're cool. You slide up, slide down, slide left, slide right, even the reflections are cool because like Lanisha, you talked about this earlier. Like you don't really memorize the formulas for the coordinates. You do it like conceptually, and you like are so able to see it. Like I'm more like a formula guy in terms of that. Dilations are cool, but then when you like got to dilate like straight lines, like it gets a little tricky sometimes too. But but so as a parent, you know, don't be discouraged. Like remember, it's a marathon. It's not a sprint. And this like note taking in math is like it's a habit and a practice that you have to develop over time, right? And your children have to develop this habit, and this is something that has to be taught. And it may vary from the level of math that they're in. Because your notes in a calculus class may look different than your notes in a seventh grade pre-algebra class. Maybe a similar concept or structure of their notes, but they may look very different. So give yourself some time and just commit to the process, commit to the marathon.
I'm gonna say, for the parents, know what kind of student you're working with. And just because they receive a math workbook or notebook, whatever they get from their school, it doesn't mean that they don't have to take notes. Just because they fill in the numbers in their math workbook and things like that does not mean that they don't need to take notes. So you all can kind of work on these note-taking strategies at home, even if your teacher is not making it a requirement for your student. The reason I say this is because as we started off this recording talking about math, you can always go back and reference it, right? The numbers change, but the types of problems really don't change. And last but not least, I'll say, remember, one of the reasons why note taking is important is because you remember 30% more of what you write down. So when we write it down, when we have our kids write it down, we've just increased their chances of retention.
I had to let that settle in my spirit. You hear that a lot, just about how important it is to write things down because it helps for it to really sink in. So it's important for parents to hear that. So when your kid is going to school, they shouldn't be going to school empty-handed, right?
Oh Lord!
So make sure you get your supplies and things. So if you need something, let somebody know. If somebody come across this video and you need something, legitimately need something, and you don't have a way to get it, please reach out to me because I'll find a way to get it to you.
We get you some resources.
We're gonna get you some resources because at the end of the day, your child should not be. I saw this too much last year where kids are coming into class, they're getting a piece of paper off the teacher's desk, they're doing whatever they're doing in class, and then that paper ends up on the floor, in the trash can, balled up somewhere at the back of somebody's head, and it's just not helpful for anybody. So I think as parents, we have to understand the importance of notes. Like Dana just said, you're going to increase that retention just by them writing it down. So since we know that they can't go to school empty-handed. So they need to have something. Then, like Akil said, be patient with yourself and understand that if this is your first year starting notes and checking your child's notes, don't be balling up your lips, getting mad at your kid if they don't have it perfect, because you got to give them some grace and give yourself some grace as well. And then another point is that the mathematicians aren't perfect. So not only are you giving yourself grace as you are building this new skill, but just give yourself grace as you're learning, period. So tonight's session was so exciting for me because one, I love to dig into stuff. I love to hear how other people look at things and process things together. But most importantly, I like to provide benefit and resources to the people who are going to come across this, because the reality is we don't know what we don't know, right? And unfortunately, there's a lot of unanswered questions that we may have. And I just want you guys to get a little bit closer to whatever your solution is. I think it's Dana that says he's the solution to their math problem?
I'm the solution to your math. I got the solution to your math problem.
So anyway, thank you guys so much for joining us tonight. I appreciate Akil and Dana, as always, for coming together with me, because again, we love to dig into all this math because all of us have the potential to be young gurus in mathematics. And I want you all to bud and bear fruit. Until next time, peace.
Deuces.
Peace.